Hello and welcome to this PV Tech TechTalk Product Series Webinar with JinkoSolar. Our guest today is Andrea Viaro, Head of Technical Services and Product Management at JinkoSolar Europe. We will be introducing the Tiger Pro, the world's first 580 watt peak solar panel that's specifically designed for the utility scale market. The intention here with our product series is to give people the opportunity to understand what is essential to utility scale projects, what are the challenges that people face, and importantly as well, give the reasons, the solution to those problems that utility scale projects need, which again, we're seeing a complete shift in the industry to larger modules that have higher output that are clearly designed to lower the LCOE of projects in a market where obviously we're going more and more towards grid parity. So want to let everybody know that we will also have a quick Q&A at the end of Andrea's presentation, and you have the opportunity to post questions in the box on the webinar, and we'll try and get through as many of those at the end. So basically, we're ready to start, and Andrea, over to you.
Thank you very much, Mark. Thank you for your very kind introduction as always, and thank you also for the many people attending today's webinar. And it's a pleasure, and we're glad to introduce today our new product series, the Tiger Pro utility scale product that is brand new in the industry and addressing specifically needs for utility scale installations, big PV parks. And of course, we will hopefully take the chance also to guide through innovations and features and benefits of evolutions of PV technologies, PV module technologies, so that the audience can have a better understanding of what technology is leading to, and especially why and what benefits are actually brought to the downstream and to investors and developers of PV projects. We start from the concept that any technology evolution or improvement is ultimately aimed to reduce simply the energy generation cost, simply not because it's something simple to do, but that's because of the fact that that's the real and main focus for all the operators and all the parties involved into the PV value chain. The level of LCOE that we saw in the last years dramatically reduced, and also thanks to the PV technology improvements, becoming even already now comparable or even cheaper in some areas than fossil fuels, and even compared to other renewable energy generation sources. And in terms of technologies, that's possible to be achieved thanks to the fact that evolution allowed to increase significantly the efficiency of the components, the PV cells and the PV modules used for the deployment of PV projects. And as shown here on the left-hand side of the chart, it's clear how the main focus of all the cell technologies and PV modules technologies is really around high efficiency cells, PERC technologies, and even going on moving towards probably an N-type technology as well, to increase even further the efficiency of the PV modules and to improve the benefits that we have at LCOE level and PV plant. Another mainstream trend that we have in the industry is clearly the bifacial technology. It is not new, since introduced in the market already since a while. We already launched last year, for instance, our Swan series, which is also with special features in transparent backsheet solutions, which have also extra benefits compared to the dual glass version. And all of these evolutions are, again, clearly aimed and coming from the analysis of what benefits really can be brought to the downstream segments, and how we can really increase efficiency and performance of PV modules to support this reduction of LCOE and increase on profitability clearly of the PV investments. From the manufacturing side, it's very well summarized in this chart. I think how steep was the increase on efficiency on PV modules that we launched at Jinko in the past years. We moved from mostly polycrystalline technology represented by the Eagle series in the past, then back to 2018, introducing the Cheetah based on mono-PERC high efficiency cells, the Swan bifacial solution, and today with the Tiger Pro, and of course based on technologies which have been used and launched already last year with the Tiger previous series that is using the same technologies and similar features that we have in the Tiger Pro. We are targeting already efficiencies which are really significantly higher than the previous generations. We're talking about modules which already have a power class exceeding 500 watts. In the industry, there is different announcements on that class of modules, group of modules, which are characterized by a very high efficiency exceeding 21%, in our case 21.6% on the higher power classes available. And in terms of technologies, how do we achieve that? Is a combination clearly of evolution of technology, innovations, which is the strong focus of our R&D team that we have in-house, but also based on mature and consolidated mainstream technologies in either cell types, cell technologies, module configuration, and evolutions on that, which add on incremental efficiency, incremental power class, higher performance of modules. So for instance, in the Tiger Pro series, we can very nicely summarize here, see the combination of technologies that we used to combine into these modules to achieve these higher power classes and high efficiency. The cell technology used is the same mono-PERC, monocrystalline PERC technology that we employed since a while, since a few years already for our Cheetah series, especially with the half-cut configuration, which is already mainstream since a while in the industry, and of course also related to the fact that cells and wafers are becoming larger and require a better combination of cells into the module to mitigate losses and to increase the performance of the module. And the real innovation, the real change in the Tiger and Tiger Pro technology and module series is the tiling ribbon solution, which allows to increase the module efficiency by reducing the gaps between cells, increasing the packing density, the packing factor, and the energy, the power density that we have in a module, and also combined with multi-busbar interconnection of cells, which is not only reliable but also increasing the low light, for instance, performance of PV modules in the field. The fact that we use mono-PERC technology for cells, it's also a nice transition towards bifacial, because that's also something that we can implement also in the Tiger Pro series, which is available in both monofacial and bifacial solution, thanks to the fact that, of course, we have already a passivated cell technology, which is an easy transition towards bifacial cells and bifacial modules. Tiger Pro is new. It is launched right now in this moment, and it is based, of course, on new technologies, innovations, but also on mature ones, as I said before, on cell technologies which are already used and proved in the field since a long time. And the fact that we launched Tiger series and Tiger technology with the tiling ribbon technology at the end of last year, it also allowed us to acquire, in the meantime, a few track records and projects that we delivered with this technology. We already have delivered or committed to deliver already a couple of gigawatts of modules, which is, of course, significantly also highlighting how it is possible for a company like Jinko to scale up and to integrate these technologies into mainstream production processes with an easy transition. So to move towards even higher efficiency, higher technologies, and improved technologies, but based on also production processes which are already used since a while, and that's also the strength that the integration we have at Jinko allows us to achieve. The main focus is on the utility scale side, as you, Mark, were saying correctly at the beginning, because clearly modules are also very large, tending to be larger and of course also heavier in field. That's natural evolution of the technology, also to maximize and to optimize the BOS and the construction and the integration of PV modules into the PV systems. The main class that we have already consolidated since historical trends is the 72 cell format, which is already mainstream and it's already accepted and well used in the market. The new trend that which of course we also want to launch, and we see also benefits on that evolution as well, is on the 78 configuration, which is a larger module, total module, achieving of course even higher power classes. Probably still will require some consolidation and better integration into trackers probably and BOS, but clearly sets a new standard and incremental benefits, extra benefits on the utility scale project, thanks to the fact that, for instance, we can install less modules and having BOS cost reductions thanks to the larger area of the PV module. But in this case, focusing on the 72 TR, the 72 cell Tiger Pro version, we are talking about a module which has a power class of 535 watts, so possibly the most powerful module of its class in the industry today, with the highest efficiency, also thanks to the TR Tiling Ribbon technology. And that's of course achievable thanks to the fact that the packing factor and the combination of cells into the module allows to have higher power density into the area of the laminate, and of course also extra benefits, extra features actually allowing to increase the performance of the PV modules. For instance, the thermal behavior is also improved, giving a better temperature coefficients, and also thanks also to the fact that we've proven the technologies of the cells and the modules used in this Tiger Pro version already in the past partially, allowed us also to improve not only the warranty conditions, but also the real degradation level of the modules to a higher standard as well. We're talking about a module that is degrading only 2% in the first year, for instance, and 0.55 on the annual degradation. And talking about the bifacial, even lower than that, because we talk about 0.45 annual degradation. So the features of the modules clearly keep improving. And talking about bifacial in particular, and that's of course the reason why it's also available for monofacial and bifacial version, is of course the utility scale application of this kind of modules. It's kind of already accepted and well understood in the market, as we see many customers and many EPCs and investors already use effectively bifacial modules and develop bifacial plants since actually a while already. It's a technology that is already proven in the industry since many years indeed, and the benefit of having a bifacial power plant is very directly related to the reduction of cost of electricity generation, because of the higher power gain that we have on the rear side of the module, which can really target the 20 or 25% by using the same PV array, the PV module area, but thanks to the rear side generation of the modules, which increase the overall performance and production of the PV plant. Clearly, talking about new standards and new set of modules, new type of modules, we can't avoid anymore, or let's say we need to take into account even better, even more now, the integration of PV modules into the complete system. The BOS, of course, is taking even more importance today, and despite the cost of modules is probably still the most expensive component in a PV plant, but the importance of the integration of the PV modules into the system in terms of geometry of the module or mechanical properties of the modules then talking about mounting structures and trackers in particular is taking more and more importance, is having more and more importance going on with this evolution of the technology. And on top of that, also the electrical parameter, different features of the module sets new challenges, but also new opportunities to reduce the BOS cost. But of course, we need to make sure that the modules is fully compatible and fully working well with the rest of the components used in the PV plant. So that's why, even especially talking about this new group of modules with larger cells and wafers, which have clearly larger current, higher current level, operating current, it's important to make sure that the compatibility with the inverter, especially with the smaller string inverters, for instance, is confirmed, and it's putting the modules in a condition to work efficiently and without increasing losses, but on the contrary, improving the performance of the PV fields. Then, as we said at the beginning, the main focus, as we know, is the reduction of the cost of electricity generation, and clearly the technology evolution supports that, thanks to the higher efficiency of PV modules. Not only the size. The size is probably not the main parameter anymore. Of course, it's important to make sure that modules are compatible and fitting well on mounted structures, and even the stringing and the cabling for the strings is of course suitable and compatible with the usual installation methods that we have already consolidated. But clearly the profitability of the PV plant, especially talking about utility scale projects, is the real focus, is the main focus for the investors, for the developers. And a higher profitability can be achieved, of course, by reducing the cost of the components used, but also increasing the efficiency and the performance of the modules, or increasing the energy generation of the PV modules. And that's through, of course, reduction of the leverage cost of electricity ultimately. And that can be achieved in this case, for instance, as shown in this slide, by increasing the efficiency of the PV modules. The Tiger Pro series, which is available, as I said, in both monofacial and bifacial version. In the central column, we have the figures for the monofacial solution, and on the right-hand side, the bifacial. If compared, for instance, with other typical features that we would expect on larger wafers and cell modules group that we have in the industry, equivalent to the Tiger Pro series that we have developed, which is represented in this case, the typical larger module with a similar power classes on the left-hand side of the chart here. We clearly see how, by increasing the efficiency of the module and therefore the power class, of course, accordingly, by keeping a similar geometrical features, is possible to reduce very significantly the LCOE level already with a monofacial modules, but even farther with a bifacial, thanks to especially the extra energy generation and power of the module, which of course is reflected, as I said, on the profitability and the return on the investment. The fact that there is such a big gap between a similar group of module similar features with 500 plus watt peak on the module level, while we talk about 530, 535, is the fact that in this group, of course, we're talking about modules using probably a half-cut cell configuration, but not a tiling ribbon, which is the key parameter to increase efficiency of modules, to increase power class, to reduce BOS costs because of the lower quantity of modules used, because of the higher power density of the PV array, and that's directly related and explaining the lower level of current cost generation and profitability. So to summarize, clearly higher efficiency modules can clearly set a new standard, not only in terms of dimensions, but more importantly, in terms of efficiency, and to reduce the BOS cost, which of course allows to reduce the LCOE level, and making PV projects, utility scale PV projects, more profitable, and of course increase revenues and energy generation thanks to the technology evolution that we can keep including in our new series of modules like Tiger Pro, the Tiger Pro generation. A new challenge for us is also not only in terms of technology of modules, but also, of course, for mass production, because the strength of Jinko is clearly being able to scale up and ramp up production very fast, thanks to the fact that we have an integrated in production starting from wafers and ingots pooling, so we can clearly control also the standards and the specifications starting from the first components of the PV modules. But of course, the challenge is clearly also to adapt production and fine-tune production to achieve that. Despite that, the strength of Jinko is, of course, also to be able to control that in-house completely, the complete value chain. And that's the reason why we already plan for next year to allocate about half of the capacity that we have already for production to this Tiger and Tiger Pro technology, which will be starting mass production in the Pro version already in Q3 this year, while the Tiger already started in 2020 Q1. This will be, of course, taking a little time to be fully ramped up, but the evolution is fast enough to sustain that of technology and production processes to be able to deliver a large quantity of modules and at gigawatt scale production already very, very soon. Thank you very much. Mark, I give you back the word for the Q&A session.
Thank you, Via. Andrea, what I see here with some of the questions, I'm just going to summarize one or two. It's focused on the 78 cell module, because obviously that's the largest in the series. And I guess a key aspect here is how does this impact container packaging? Because obviously the whole purpose here is to drive down the overall LCOE of a utility PV utility scale PV power plant. But there's pros and cons, and I think people are just trying to understand that impact from a transportation point of view. Perhaps you can give us some ideas on that.
Yes, actually, very good point as well. In reality, of course, as we were commenting during the presentation, the fact that modules cannot be designed or thought like individual standalone components, but completely integrated into the PV system, and that's of course also related to logistics and transportation costs. Clearly, we know how critical are all the items and all the parts of the capex and opex to influence LCOE. And transportation clearly is one of them, probably not the main one, but clearly as costs of components is going down, the other items are increasing importance in the overall balance. So also transportations in terms of cost, but also in terms of environmental sustainability, and the fact that we can, for instance, pack more power into a container with this new high efficiency technology also helps to make the technology also more sustainable from the transportation and pollution point of view. We can save, of course, the quantity of containers used to deliver the same quantity of power. Just to give you an idea, comparing our previous Cheetah version 410 power class with our current Tiger Pro 535 watt peak class, we can pack 10% more power into a container. So you can, I think, easily understand how that impacts very directly the transportation cost and the quantity of trucks or lorries needed to transport the same quantity of power. So rather than wafers dimensions or module dimensions, it's important, or quantity of modules in a container, of course, the main parameters and the real metrics of module quality and the overall LCOE is really the efficiency of the modules and, of course, the power that we can put into a module and in a container.
Okay, I've got that. Thank you. Just keeping with that theme, because I said there's been questions on this, and you do highlight in the presentation that compatibility aspects, and people are really asking, especially let's just use the 78 cell module, the Tiger Pro module specifically, is what's its best uses when you've got challenges with inverters with that much power. And I think as well people are referencing, say, the bifacial module in this size from maybe a tracker, single axis tracker perspective. So perhaps you can give some clues as to what works best with what, or what's the idea here.
Absolutely, and I think we are very aware of the fact that the 72 Tiger Pro, 72 cell Tiger Pro is probably the easier to introduce in the market, because it's already a standard format that we have in the industry in terms of dimensions, but also electrical parameters. So the configuration of strings and design of PV trackers, it's of course an evolution, but somehow already consolidated in the past. So the 78, on the other hand, sets new challenges for sure on integrating those type of modules, especially with larger area, into the PV system, and especially for the compatibility with PV trackers. That's why we expect the 72 cell to have higher success at the moment, and to be more easily accepted by the customers. But the 78 for sure allows to increase or to reduce actually the BOS cost, because we can of course clearly reduce the quantity of modules installed in a PV sites thanks to the larger area. But it is clear that for some regions or in some locations probably, or especially for some mounting systems, it's not yet, I would say, the best fit, because it sets challenges or limitations on the wind pressure, for instance, or the robustness of the module, or the mounting structure or the trackers could be stretched too much to the limit, probably not to allow a very stable and reliable performance of the PV modules and the PV field in the long run. So clearly, yes, 72 module, especially for the bifacial, and depending on the typical configuration that we have, it's a normal one portrait or two portrait, but especially in the two portrait, the 72 already is 2.2 meter tall, so already reached the limits of the tracker configuration and tracker robustness probably in many locations. So that's probably the best fit for most users, either monofacial and bifacial. But 78 really, in some locations we expect also to see that deployed and used more going on, once of course the BOS or the integration with the trackers or the rest of the components will be fulfilled.
Okay, that's a good explanation. I think that answers quite a few questions in one there. I'm just going to shift emphasis a little bit. You also mentioned, obviously, with the technology, the ribbon technology, half-cut cell, and someone's here's picked up on the fact that you've got the degradation rate, annual degradation rate down to 0.55%. What they're asking here is how does that, is that impacting the warranty? What's the warranties like for this type of module?
That is true. Yeah, probably. Yeah, it was probably not so clear when I explained that through the presentation. But in that case, I was actually talking about the warranty conditions. So to that extent, actually, the 2% initial reduction in efficiency, or 0.55 annual degradation, are the warranty conditions for our Tiger Pro series. On the bifacial, it's as I was saying, even lower, is 0.45 annual degradation. So those are actually the warranty conditions, which means the worst case scenario situation that we can imagine in a general installation in worldwide, which means that actually the modules are expected, of course, to perform better than that. The fact that we used this cell technology and similar half-cut configuration, or some of the technologies used for Tiger Pro already used in previous series, Swan for instance, for the bifacial, and cheetah for monofacial half-cut cell, allowed us to gather track records and information about the model behavior in the field, and ultimately to improve the warranty conditions and give all this extra value to the PV project developer and investor to increase the profitability and of course give even extra value on the business plan when developing or investing on a PV plant.
Okay, thanks for that one as well. I'm just going to, looking at the time, I've just got one more question here for you. It's actually, I'm collecting here several, I'm watching here some of this, but maybe to summarize, maybe clarify availability for the Tiger Pro, but also people are really asking, because obviously this is a utility scale product. They just wanted to understand the actual capacity expansion plans for this, because obviously you've already got the Tiger series in production. What's the just maybe give some better understanding for people about the true total capacity that's going to be shifted over to Tiger. So it's both the capacity side and the real availability, I guess people are asking.
Totally, no, clear. And actually, yeah, seems an easy question, but actually the situation is rather complex. And of course, the fact that we have many evolutions and innovations in the PV industry clearly sets new challenges on understanding what type of modules has to be allocated production to, because the possible combinations are actually different. And we didn't even mention about N-type, for instance, which is also a possibility for, of course, also for our Tiger solution. The fact that we control in-house the complete value chain also allowed us to keep flexibility and to control the capacity allocation to the specific type of products that the market needs. So we can achieve that, of course, because we can control production starting from the wafer size, from the module size, ultimately also, but controlling the complete value chain, we can flexibly adapt and deliver to the market the product that are really the best fit for the specific segment. Talking about absolute capacity, we were talking about the 10 gigawatt for next year. We already have capacity of between 2 and 4 gigawatt for Tiger technology in terms of TR, tiling ribbon solution. Of course, the higher size and wafers of cell size for the Tiger Pro will require specific capacity allocation. But again, being able to produce the wafers in-house and controlling that part, we are confident we can practically achieve 10 gigawatt capacity for next year and starting to deliver the modules already from Q3 this year. We are already discussing first orders clearly for the next year, so we expect to be on time on this roadmap. And for the Tiger, in terms of technology, as I was commenting earlier, we already have a couple of gigawatts signed order and delivering modules already. So that step of production is already implemented well and does not represent a bottleneck in production. So we expect to ramp up according to the roadmap that I was discussing, and not having surprises about that, especially because we really expect Tiger technology and Tiger Pro, especially for utility scale project, to become the new standard module for that segment of the PV industry. And that's why we are promoting and, of course, discussing with the downstream market and customers to really make them understand and appreciate the benefits and features of these modules.
Okay, thank you very much, Andrea. Thanks to the attendees here and the good questions that they've asked. We've reached our time limit, so I'd just like to say thank you very much to everybody, and goodbye.
Thank you very much to you, Mark. Goodbye, Cole.